Hello, it's Monday. I hope you had all had a good weekend. I don't think I've got a tremendous amount to say today, so we'll see what it ends up like. I'm still kind of vaguely chewing on phone number addressing. I'll probably go through. I wrote some stuff over the weekend. We also had some folks write some discussions that I'll probably bring up and chew on. I know Aria wrote some stuff up, and I know Rem wrote some stuff up, so I'll take a peek at those. There's also been some mentions in the chat, or there's been some chatting about it, so I'll probably go see if there's anything on there to jog my brain about it. We're definitely until the end of the year, we're probably in like slow roll mode for Ergot, so if we get this sorted out, I'm pretty happy in the next couple of weeks. Might take a shot at implementing this at some point, but I'm still kind of chewing on it and figuring out some core stuff. So if you weren't here for the last stream, it's the last one that has a phone, like an old school rotary phone on it. But the goal is to set up a new kind of addressing, and so we're kind of like thinking through right now the extent of the idea and what is covered and what's not covered and things like that. So I have a gist open. I've linked it in I think I actually did link it in the top discussion. Moving to phone number style of addressing. I have the work in progress draft here. So if you want to click on the actual document that I'm clicking on, you are welcome to go check that out. And we'll get back to this. But if you want to look at the actual document that I'm looking at and not just like try and read my screen or try and copy down the gist URL, it's actually there. So yeah, this is phone number addressing. This is something that's vaguely inspired by how phone numbers work, also vaguely inspired by CIDR or CIDR or classless interdomain routing. Does like sort of variable length prefixes and stuff like this. But I've started writing this up mostly like RFC style, like probably more Rust RFC style than Internet IETF RFC style. But yeah, the motivation is mostly that we can dial local numbers using a shorter number, we can dial further away numbers using a longer number, and that the local numbers are stable. They're a pure suffix of the longer, further away numbers. So I go through some explanation, like if you were inside a building, you might be able to use a 4-digit number to get to a room. Outside of that, on the street, you might be able to dial like 678 1234 to get to that same room 1234. And then if you're across town, you might need to have an even longer prefix on there, like 808 678 1234 and stuff like that. So the idea is that like you notice like this is the same all the way through, and then from this scope upward the number's the same, and that's sort of the idea, is that like when you're just an apartment building, or actually like the better metaphor, and I might switch the metaphor to this because it's kind of better match for what I'm talking about, but almost like a cruise ship. So if you have like a cruise ship that has a stable number, and then you kind of like come to port, and OCR copy paste was actually quickest. Nice. If you come into port in one place, you get assigned a prefix, and then if you move your ship somewhere else, you might get a different prefix, but inside of the cruise ship, all the numbers are the same. That's more like our sort of mobile device. I keep holding up this Clockwork Pi PicoCalc, because that's sort of my example of like, okay, what if we had a small network inside of this system, and then you plug in USB, and then I go to someone else's computer and plug in over there. I don't want any of the addresses on the device to change, but it has a, larger scope. Damn, James, now I want to go on vacation. Have I ever been on a cruise ship? I've been on a cruise ship, but I've never been on a cruise. I had a family member taking a cruise, and like before it departed, I got on the cruise ship. I've never actually taken a cruise before. But, I get having a hotel room and getting to see new places for whatever, pluses and minuses cruise ships have. Yeah, so that's our primary motivations of the scheme. We can use shorter numbers locally because we're sort of going to compress addresses. This helps. So smaller numbers means better compression. And that zones of devices can travel together and stay stable even when they move to new whatever. And sort of the downsides is that this will probably only work on hierarchical networks. So if you run like real internet stuff and you have backup links or like loops in your routing, like if you have sort of like 3 offices and each of them have a connection to each other, probably won't work for that. Maybe it will. Maybe someone smarter than me will figure out how to make it work. I can't figure out how to make it work. But it's also not a problem because those aren't the networks that we're talking about here. And we don't have to be everything for everyone. I invented a new notation, and I think it was Titanium Traveler, or maybe it was Anatol, I think. So CIDR notation has like /n. So if you say like some IP address /24, that means the first 24 bits are the prefix and the last 8 bits are the host address. But that sort of starts from the left. For me, it's easier to think going from the right. So I used a slightly different symbol. So we're using like the caret operator instead of a / operator. And this means I'm counting from the right. So it means that caret 8 would be 8 bits significant. Because like in phone number addressing, we're just not using the tail. It's not like we're splitting it between network prefix and address. We're just saying semantically meaningful address and then upper whatever bits. So this is a right notation. And I'm also calling it PNA for phone number addressing. The other nice thing about going from the right is that if we eventually want 64-bit addresses, either like concurrently or it's a choice, then these numbers all still make sense. And then I just say you should probably write them using hex. I don't know if that's what people really want, but I don't know. It's how I'm going to use it in this. We'll see what it actually ends up being. So we're sort of merging. We used to have what was called like a static class network, where the biggest class was net ID, which are net segments, node ID, which are addresses, and then ports. My dog is very upset about something. Okay, he's being taken care of. So we're just merging those all into one big pool. So the big part of it is I've started calling these address allocators, and address allocators is just a fancy word or fancy phrase for like something that hands out ranges. Because in all these phone numbers, we're thinking about ranges. When in like decimal, if we have a 4-digit number, that is a range of 4 digits, or like 0 to 10,000, basically. So everything there's going to be a lot of pieces of the system that are responsible for handing out chunks. Which makes them very allocator shaped. This is the same way that like a memory allocator works, in that you give it a big pool of memory and then it hands out little chunks inside of that. So it's handy to me to think about these as allocators, because they're basically allocators. So every allocator is going to have their pool of stuff that they can allocate from, and then they're going to have to maintain some list of allocations. So what if they handed this out? Because they can't keep using it if they've handed it out. So a device might hand out a chunk of it to itself so that it can use those for sockets, and then it might hand out big chunks to downstream devices. So if it has children, it might hand those out. So yeah, like I was, we'll get to that. And I kind of define apex entities. I don't know if this really needs a name, but it's basically like whoever's at the top of the tree. So if you don't have any parents, you're an apex entity. And technically, you're allowed to use the entire 32-bit or later 64-bit address spaces you want, because you don't have to negotiate with anyone. There's no one above you. But you still might want to be a little conservative, because you might get plugged in later to someone. Because like every device when it boots up, before it's established any network connections, is an apex device. But that might change immediately within a couple milliseconds once you start talking to people there. Apex entity. Did I spell something wrong? I don't know why Alexandra put that in quotes. If the 3 offices on the same layer of the hierarchy, it should be fine to do some alternative routing looping. What would mean is they share one address allocator. Yeah, that one I don't know how you would have like a virtual parent but no actual parent. Like I said, maybe there's probably someone smarter than me who could figure out how to make it work. I still want to know what I said and why Alexandra put apex entity in quotes. I probably said something silly. Oh well. Yeah, but so you still might want to play nice, because you could eventually get a parent, At which point, if you decided to use a huge amount of the space and the parent doesn't like that, it might be upset. And again, we're talking about compression. The smaller address you use, the more compact they are when you're sending. So, okay. Just making me anxious for no reason, Alexandra. Downstream entities. So anything that has a parent is a downstream entity. So this means that you still need to hand out addresses, but kind of your max scope is not necessarily the full 32 bits, but whatever your parent gives you. Because if you have a parent, you can only play with the address range that they've given you. So you'll have to request a range from them, and then you'll be able to use that. So it's kind of like whichever process 0 on your computer gets the full address range, and then it might divvy that up to, individual. It's not really, I shouldn't make the OS metaphor because there's virtual memory and stuff like that. But so then I talk a little bit about initializing the address allocator. So we say that, hey, we think we need a 10-bit address space. I'm pretty sure that I usually use 10 because I know 10 bits is 1,000 or 1,024. So a lot of my examples are around 10. So we say, okay, we think we'll have about like 1,000. We'll need about 1,000 addresses. So we'll start with a. I need a better name for this. Like it's not a /10. It's like it's not a bang because that's an exclamation point. It's like up 10. I don't know. 10-bit address space. And so we start our allocator. We say that we have 10 bits. So that's 00 to 3FF or 0 to 1023. So now we go, okay, cool. We have a range for allocating. Let's say we want to give ourselves room for 128 sockets. So we shave off a 10-bit range suitable for this. So our first allocation out of our 10-bit range is a 7-bit allocation. So we're going to allocate that 0 to 7F or 0 to 128 non-inclusive. So that means in the 10-bit address space, anything 000 to 7F in the 10-bit address space is referring to us and our sockets. So that means that we still have a bunch of unallocated space. We have 080 to 3FF in the 10-bit address space eligible to allocate. So we could carve this up in a bunch of different ways. So we could place a single 9-bit address space. So if one of our children wanted a 9-bit address space, we could hand it out. I'll explain this unaligned stuff in a second, but that could either be 100 to 2FF or 200 to 3FF, which is basically like 256 to 768 or 512 to 1024. So like a contiguous 512 address range. We could... Oh, that's weird. There's a syntax error there. Why is there a syntax error there? So we could have like 256 to 128 to 256, 256 to 512. I don't know. I'm probably off on this. What is this? 256 to 512. Can't do math. 128 to 256, 256 to 768. I don't know, whatever. I can't do math right now. But yeah, it's in quarters, and we're using the first quarter at least partially for our address range. We could shave up a bunch more 7-bit address spaces. So this would go from like 128 to whatever, 128 to 256, 256 to 192. I don't know. I can't do math. Don't ask me to do math on a Monday night. And so on. So like we could even carve it up into smaller spaces and stuff like that. And so I'm basically just saying your allocator, just because you gave out a 7-bit address space doesn't mean you have to only hand out 7-bit address spaces. You could hand out bigger or smaller address spaces and things like that. So one weird thing that I haven't totally wrapped my head around is whether we should allow unaligned allocations or not. Because technically this 9-bit address space isn't on like a perfectly even distribution, because like if you have like 0 to 1024 and you go, okay, I have a 512-bit division. If you were to divide it evenly and aligned, it would be 0 to 512 and 512 to 1024 are your only two choices. But technically you can take your half out of the middle. Like you can have your 256 to 768 in the middle. Rem is sending me the math. Yeah, it's 512 to 768. If I really wanted to pull up Python, I could do the calc here. I don't know if that's a thing that we want to be able to do, is be able to take things out of the middle. It's one of those things where I'm like, it feels like we shouldn't be able to, but I can't enumerate a reason why we shouldn't do that. The thing that I was thinking of is we don't have like a clean prefix in front of it where you take like the 1 bit in front of it, because when we're dividing up a 10-bit address space into a 9-bit address space, you'd think that we just have like 1 bit in front of it. And so if it's 0, it's 0 to 512, and if it's 1, it's 512 to 1024. But this kind of is like between 0.5 to 1.5, which is fine because you can do an addition instead of like just a bit masking. But yeah, I don't know, it's funky. It means that there's probably some requirements there that I'm going to need to figure out, and they are not immediately clear to me, and figuring them out. So this is sort of where I'm working. I kind of want to play this out. I'm going to keep writing this probably when I get some time to do so. But yeah, I'll keep working on this. So I'm going to go to Aria's proposal, which is an interesting conversation in that we sort of need to answer the question. So I said that you have to ask your parent for space. So if you boot up and you say, okay, I have 1024, you connect to a parent, you tell the parent, hey, I want 1024. They say, sure, here's your 1024 range. Enjoy it. Have fun. And you go, wonderful, great, that's me. But then you have a child plugs into you, and the child wants another 1,000. And that's a problem because you only have 1,000 to give out, and maybe you've given them out for some other things. So what do you do at that point? And so, one easy answer is you just say you can't. And everyone has to guess right. And if you ever have a child who plugs into you who wants more than what you have, you just say no. This is sort of the, panic out of memory, but for addressers, for address ranges. There's two other choices we've sort of thought of so far. So the one that I came up with originally was that if you decide that I want 1,000 and then you realize you need more later, one thing you could do is tell your parent, okay, I'm going away, bye. And then when you're the only apex person, because now, if you've gotten rid of your parent connection, you're now the apex, you're the top of the range, and you go, haha, I'm immediately going to go from 10 bits to 12 bits or something like that. And so now, instead of 1,000, I can have 4,096 addresses. Great. And then you reconnect to your parent and you say, hello, I am a brand new device. You've never heard from me before. I would like 12 bits, please. And hope that your parent then goes, oh, sure, yeah, I've got 12 bits. Here's your 12 bits. And then everything is hunky-dory. Not really, because anything that you were talking to outside of your parent, you've now changed addresses. So anyone who was talking to you before thinks you've gone away, and then a new device has shown up. And if you were having any conversations with other people, your addresses have changed, so all of a sudden, your source address may not make sense to them. So that's not great. It probably works, and it might be acceptable. It's very simple, but it's not great. And there's a potential problem where if you go, okay, now I'm 4096, and you try and connect to your parent, and they say, oh, no, I don't have 4096 either. They either need to go to their parent and keep reallocating, but at some point, if you run out of space, someone's going to go, I guess, no. You still have to sort of answer the question, what happens if the answer is no at some point? And not just wait, okay, I figured it out. But what happens if the answer is no? And that is, do you boot one of your children off and then try and renegotiate back for the 1024? I don't know. Probably it won't be a problem, but it might be a problem. So we should probably spec what it should do in that problem. Even if everyone goes, hey, we don't handle that, at least we know what it should do. Aria came up with a good suggestion in that, much like memory allocators, you don't necessarily need to have all of your allocation pool be contiguous. So I had sort of written this always saying like, I'm going to have a contiguous range. Like I'm going to have 0 to 1024. Arya very rightly noted that you can have allocations that are non-linear. So you have like jumps, and like a lot of allocators work like this. Like if you need to request more space from your operating system, some operating systems will just resize your memory to be larger. Some of them will go, okay, you have one chunk starting here and another chunk starting somewhere else. And so another option would be to have an allocator that was smart enough to handle non-linear blocks. And so if you had a child show up, so if you've allocated most of your space, not all of it, but most of it, and then someone shows up and wants another chunk and you can't satisfy that, you might request another 6-bit block for this. And so then you'll have one that starts at 04 and one that starts at OC. So this would be like 04, I don't know, whatever. This is also using like a sort of cider notation, so I can't do the math super easy. In Arya's defense, Arya wrote this before I came up with my fancy notation. So basically, yeah, you have another block. And that way you can hand out addresses in that space, and things are lovely. It does make the allocator a little more complex, and it makes the routing a little bit more complex because you're not just looking at one block. You kind of have to look at all your blocks, but it's not an insurmountable problem. And it's not, in practice, it'll probably won't be a lot. So this is very reasonable. We just have to think about how we handle this non-linearity, or like the fact that if you were to walk through your space, it's like logically this child has 4 NC, but there's kind of this other device that lives in the middle of your address range because it's like 04, 08, OC there. I don't think it's a deal breaker though, and I think it is probably nicer because instead of having to like double or quadruple your space just to get a bigger space, you might be able to just like add a little more space. But then we have to figure out like any allocator, it's like fragmentation. Like what do I do when I have a ton of little blocks instead, and what can I do to condense that? Or, you know, when I'm writing on a no standard device and I only have, like, let's say I only have room for 4 slots. What happens when I exhaust my 4 slot thing? Do I try and condense? Do I say no? Like, for all of these, we really need to, like, just kind of think out the exhaustion point, because that sort of informs what we do. So I'm saying stuff about multicast address. Remrevo is saying offsets are kind of weird, but feel like they should be fine. Makes the allocator harder, probably, but that's probably fine. Yeah, I'd probably agree with that. Like, I think it's possible. It's just, like, it's a weird, like, not paper cut, but it feels not smooth in your brain. I don't know if anyone else thinks like that. Like, when you have to have a bunch of, when things aren't intuitive, you go, hey, wait, is there, like, an integration seam that I'm not understanding there that I should think about? But yeah, so that's about where we're at now. I think there's still some questions to ask. Like, one of the things that I was thinking about in chat, let me make sure I think I covered most of this, but I think, yeah, because the trick is always, if you're going like up this block and up to another one, you kind of have to jump into the larger address space. But this device could still potentially handle that. Let's see. Rem did have a proposal here. I remember looking through that and it being reasonable, but I haven't. Yeah, I think this is generally talking about broadcast stuff, which is definitely a thing that we're going to have to think through, which is, yeah, I don't know. Right now, broadcast, like in our current system, anything with a port number of 255 gets treated as special. 255 is a weird port thing to have because we've kind of gotten rid of ports. There's kind of 2 special ports right now in Ergot. The 0 port is the any port, which means we kind of like look on the device for a socket that matches the qualities. And if we find exactly one that matches those qualities, we'll deliver it like a wildcard address. If there's multiple, we say no. If there's 0, we say no. But if there's exactly one that matches the qualities that you're looking for, we go, hey, you were probably looking for this one. And that way people don't have to like do a full discovery process. They can just kind of throw the packet and see if it sticks. And then when you get the response, you can be like, oh, it was actually port number 27 that responded to me. I can just remember that and do that. One interesting thing right now is, what do we do with the 0 address? And then cases where you're like talking to your parent. So if you're a device that was allocated 18010 to 1FF10, you're existing in a 7-bit space. So if you or your children are talking to you, if they talk to 0 tick 7, then they're talking to you. But what does it mean to talk to you specifically? And this is also another one of those, like, because we've gotten rid of specific sockets, there's no such thing as really talking to a device or an entity. You're talking to a socket. So what do we put at that 0 socket? And we could put the any. We could maybe even put the any and the broadcast, and have like inside of the packet have some, like, instead of differentiating based on the port number, we could have it be like a field inside of there where it says like what kind of packet is this. Yeah, I don't know. Let's see. The other thing that's going on in the discussion is like what the wire form is. So how do we encode this on the wire? Because really, whenever you send something to an address, you need to not just include the address, you also need to include like how many bits are important in here. Because if you're sending to 0 in a 7-bit address space, like if you're this child in here, 0 on a 7-bit address space means you. 0 in a 10-bit address space means your parent. And then if you go even higher to like a 12-bit, that might be like your parent's parent is that 0. So you do actually need to say, like, you know, how many leading zeros do I actually have? Because like in a phone number, if you dial 1234, that might be different than like 0001234. In phone numbers, we don't usually have zeros, but you sort of get the difference between 1234 and 0001234. Multicast address just being a property of the address, not of the packet. Only the router has to know what type it is. Interesting. Yeah, I haven't really thought about multicast. Are you making a distinction between multicast and broadcast? Because I super don't understand multicast super well on desktop routing, so I definitely need to look into your proposal more. You have talked about sibling routers that share an address prefix, because this might be a way to handle this sideways, but then we need to have sort of like a negotiated virtual parent. Definitely need to watch. I will always watch a Radia Perlman video now. Differing priority devices is also a fun idea. I haven't gotten into that. Instead of making broadcast multicast an inherent feature of the protocol, broadcast can be made by sending a request to the router to make a broadcast for you. Yeah. Open question, alternative dynamically requested broadcast multicast address. If a bunch of devices are on one connection, they all want the message. Having to send the request just next to a bunch of devices in the router and back to the device would be kind of a waste. Should have already seen the message. Yeah. So there's definitely a fun thing in here in that some of our topologies are buses. So like RS-45 is an example where you might want to send it out, and instead of it being echoed back out by the router, you might say on this link, everyone just heard that, and it's fine. But there's also a lot of point-to-point links, which is more like a switch, which if you have like 5 devices that have point-to-point links, you might want to send it up to the router who's going to send it out to the other 4 devices on the network. So that devices can just send read the messages as soon as they see them, and the router repeats the message on only devices that haven't seen them yet, according to the address tables. Yeah, I need to chew through this. I definitely don't entirely. I think I skimmed this, but maybe I didn't read this deep enough. So, Rem, I need to reread your proposal more and chat with it. I know we've chatted about it a little in chat, but yeah. Yeah. But yeah, that's mostly where I'm at. I think it's still going. It still feels promising. There's still definitely a lot of things to figure out. Some that might need to get figured out soon, and some that probably don't. That we might be able to kick down the road a little bit. But yeah, it's going. I hope everyone's been having a good week. If anyone has any questions or things to say in chat, now's probably a good time. Otherwise, I'll keep chewing on this. Feel free to make comments directly on this or on here. Oh, the other thing that we're sort of figuring out is what the wired representation of it is. This is why I was talking about we have to include what this is. So there's kind of like two ways to encode this. One is where we like kind of put a marker at the top of the bits where we say like, okay, you add a 1 above your bits. So if it's a 10-bit message, the 11th bit is a 1, and then whenever you see the most significant bit of 1, you know that all the bits after that are data. The downside is that makes variance kind of big, and it means that we can only encode 31 bits in a 32-bit address space. The other way is to have them as separate fields, basically. So to have a varant and then have a separate like byte that has the number of bits. Aria, would you like me to rewrite a proposal in James notation? Okay, I'm calling it PNA notation. But if you want to, if not, no worries. Like, I'm going to write down when I get to the proposal, I will probably transcribe yours and mine as like two options for how we do allocations. But to be honest, I think from a protocol level, the answer is we might be able to do either. I don't think it semantically changes the meaning of the addressing to have a device that can have non-contiguous address ranges. But I need to sort of write the rest of the proposal to see if that's true or not. But right now I have a note or something. I have like one line that says they don't necessarily have to be linear. I don't remember where I put that, but I thought I had that, where I say like the allocations may not be... Oh, here we go. It is not currently specified whether the pool of addresses are always contiguous or a single n-bit allocation. Yeah, refusing to expand definitely could also be an option. If you have a device that says, well, I either guess right or I don't. Or, I mean, I think there's a lot of... there are a lot of devices that won't even need to think about this because they're an edge device, and they know that they're never going to open up more than 12 sockets, basically. And so they can just request a 4-bit address space for themselves and be done with it. So I think definitely... Oh, Perlman has a book. Which book did you pick up, CBJMO? Yeah. I think Aria, to say, like, I think, and Alexander's chiming in too, I think, honestly, it's probably going to be something that happens, like, how you do allocation is going to become a quality of the profile. Because that's sort of where all of our variance is on the behavior and stuff like that. Rem is saying, would it be reasonable to have differing capabilities in terms of address allocators? I think the answer is yes. Like, how you do allocations, I think definitely is reasonable. At least I haven't gotten to a point where I'm going to say no to that yet. And I do think, kind of like what Aria and Alexandra are saying, is that it'll be a property of the profile and that there will probably be different techniques, like in the same way we have different memory allocators. Like a bump allocator versus malloc versus JE malloc or whatever. We just need to make sure that whatever rules we make for addressing are coherent with that, so that we leave enough latitude to have that freedom and not paint ourselves into a corner with having that. It's one of those hard things in spec writing, is that like sometimes you want latitude and sometimes you don't. So we'll see. I think right now my gut is saying that like we can probably guarantee that you can have, like, the rule that I would probably say is that your addresses that you can allocate must always be a subset of your parents, but your subset of your parents may not necessarily be a contiguous region within your parent. So that kind of leaves the door open, but it still narrows us down where we always know that our space is a subset of our parents, even if it's a non-contiguous subset of our parent. Virtual parent could also be an allocator impl, yeah, but then you get into distributed systems problem. And that's one thing that I'm nervous about, Rem, is that like when you have a distributed system, I mean, I guess the allocators already are kind of a distributed system. It's just like keeping it strictly hierarchical. I don't know, but I'm already kind of bailing on that. So yeah, maybe virtual parents are a thing. We just need to figure out how to spec that. So I'm very interested to what you write up. Let me scroll through. Yeah, James notation. I'm really pushing. I gave it a name. I gave it PNA notation. I don't like things named after. If you noticed all of my crates, I have never named anything after myself, like first or last name. Really don't love that. Because then, you know, if I end up being an asshole, no one can take any of my, or no one can use my good ideas for that. So, you know, not going to point out any specific markup languages or anything that are named after people. But if someone, you know, at least then if I'm an asshole, only I'm an asshole, and, you know, people don't feel bad using the tech that I invented. Plus, yeah, everyone would spell my last name wrong. Everyone leaves off the S, so I would just be asking myself for frustration. Yeah, Rem, I'm happy to discuss the stuff once you get it written up, or if I get further enough. And if I end up writing something that you want to be able to do out, don't treat this as like concrete. This is like I'm writing it up to have the conversation. Mun apostrophe S notation. I hate it. Thanks. I hate it. Yeah, whatever. So yeah, I'm working on this. Other people, I would love to have this. Feel free to, if I need to move this to GitHub or like in the repo so that we could do PRs on it, let me know. Otherwise we can keep this stuff here and I'll probably just congeal it all as it makes sense. When it gets closer to being done, I'll open up as a PR and then we can start like turning sections into it. But yeah, I'll probably keep working on this. I don't imagine this resolving immediately because like it'll take another day or two of having time to write the rest of the proposal and then some time to talk about it and then probably implement the proposal and see, at least like poke around, like maybe not have a clean implementation in Ergot, but at least like mess around and see what it breaks and realize like, oh, Ergot really assumes this is true, and as soon as you get rid of that assumption, it breaks everything. So yeah, if someone else has way more time than me, please go ahead and do that. If not, I'll get to that, and I appreciate all the feedback. Yeah, I'll probably put in last call. I gotta go take the dog out, make some dinner. Made a lot of gumbo this weekend. I'm excited for gumbo time. Let's see if I can have pictures of gumbo instead of my dog. My dog is not named Gumbo. Good name for a dog, though. Hell yeah, gumbo posting. Big pot. It's basically gravy soup. Hell yeah, American South curry. So yeah, it's gumbo time. I'm excited for that, which means my whole house has smelt like gumbo this, like, all of today. And I'm not upset about that. But yeah, any questions? Last call. CBJMO says the book from Perlman is Interconnections, Bridge, Routers, Switches, and Internetworking Protocols. I'll probably definitely pick that up. I'm going to put it next to my Inside Apple Talk book because the first chunk of it was inspired by Apple Talk. I bought this book from like 1990. It's like a reference guide. I've only used like, a lot of it's like practical how you actually use the network stack, which is uninteresting to me in this day and age, but how they implement it, they have quite a bit of of documentation of how they implemented it and like explanations of how the techniques work, and that's where a lot of early Ergot was borrowed from. Okay, I'm not seeing any questions, so I'll probably wrap up. I hope everyone has a good week. No idea when I'll stream again. Probably at least Friday, maybe Wednesday if I have something to talk about. Kind of like last week. If I haven't done anything by Wednesday, I'm not going to stream and just say whatever. Although if other people do stuff, I might jump on to discuss it. But at least on Friday, maybe on Wednesday if there's stuff. Otherwise, I hope you all have a lovely week, and I'll see you at least Friday, maybe Wednesday, but definitely in chat. Okay. Thank you, everyone. Thanks for all the good comments. I appreciate everyone who's putting in discussions and stuff like that and chatting in chat, because I only vaguely know what I'm doing, and it's good to have other people chat to it about. Okay. Have a great week, everyone.